We're going to take a look at another example in this video. Same steps as before for the graphing rational function. So our first step is to simplify. There's nothing to simplify here. That's going to come in future examples. So we're going to go right into the x and the y intercepts. Again, when you go to record this, make sure you write it as a point, -5/3, 0. I wrote it originally as 5/1, but you can definitely simplify that into 5. Again, we want to do synthetic division. So our original problem has x plus 1 in the denominator. We're going to switch the sign and make it a -1 for the corner. List your coefficients, 3, 5. Always remember, bring it down first. So you're really only going to do one round of multiplying and adding. Bring down the 3. And you have your multiplying and adding. Again, if it helps to write it out in the format you're used to and then switch the order, I think that's a great idea. So this would be 2 plus 2 over x plus 1, because 2 is your remainder. That's not the right format that we're looking for, so we want to make this 2 over x plus 1 plus 3. So that tells us a couple things. This is stretched vertically by a factor of 2. It's translated left 1 and translated up 3. That's important for your asymptote lines. So we're not asking you to write the transformations out here. It might be helpful to write out the transformations. And then the vertical stretch doesn't come into play until you do your tables. While I'm down here, I'm just going to put the domain and range on. All right, in terms of space, we have a ton of space up on the top, so that's where we're going to do the work for the tables. First, we're going to multiply the y column by 2, and then we're going to do the 2 translations. And then because we're going left 1 and up 3, we're going to subtract 1 from the x, add 3 to the y. Remember to also include your x and y intercepts. They might show up in the table, they might not. And that's it for the branches. We had no reflection here, so it kind of goes in that same direction as our original graph. All right, we're actually going to move into the whole, which will include the simplifying portion. So we're going to do that in this video because then our third video is going to kind of put everything all together. That way there's not going to be 4 videos. The first step is your simplifying. So we're going to do that factoring and canceling, and that's going to give us something called the whole in the graph, which we haven't had so far. We've only had the asymptote lines. So we're going to do our factoring. We're going to simplify. I usually call it something different because we have simplified it. So I'm going to call our simplified function g of x. Now the factor that cancels is going to be what causes the whole. So we're going to set that equal to 0. So that's your x value of your whole, but you want the whole is a point in the graph. So we're going to plug that answer into our simplified function. So we have our x value, we have our y value of the point. That is where the whole occurs. And then at that point on the graph, you're going to put a little open circle to show that that's not a point that's technically included in the graph. It's where the graph is undefined. So we're going to do one more quick example of that to wrap up this video. And then in your third video, everything's going to be put together, the graphing with the whole. So again, the factor that cancels is where the whole is going to occur. We're going to cancel out that x minus 4. We're going to write a simplified function because we need that to plug back into. So in this case, our whole is occurring at the point 4 comma 7 over 5. Right, and our last video is going to take that concept and put it together with the graphing from the first concept.